Hello everyone, myself Mr. Jayesh Mohanrao Sarvade. Today we'll discuss the topic polymorphism. As we know ki there are eight basic object-oriented concepts. One of them is polymorphism. So today we'll discuss the compile time polymorphism and runtime polymorphism, which are the types of polymorphism. Firstly, we'll see what is the definition of polymorphism. Polymorphism is nothing but its ability to take more than one form. As we know, the word poly means many, means more than one. So, for example, one person can act in two role, that is nothing but the polymorphism. So, it provides the facility to the functions to behave for different tasks. One function can be used for implementing different tasks. This is just introduction to the polymorphism. Now let us see the types of polymorphism. There are two types of polymorphism. First one is compile time polymorphism and second one is runtime polymorphism. First type is compile time polymorphism. Compile time polymorphism is the type of polymorphism which binds the data at the time of compilation process itself. It means before execution we compile the program. At the time of compilation process itself, data and functions related to that particular entity are bounded together. So it is called as compile time polymorphism. It is achieved with the help of function overloading and operator overloading. Another term used for compile time polymorphism is early binding or static binding or static linking. Let us see the mechanism of compile time polymorphism with some example. One example is given in this presentation. Function overloading, as we know, function overloading is used for achieving the compile time polymorphism. Let us see what is the meaning of function overloading. Function overloading is nothing but then when there are multiple functions of the same name and they differ in their number of parameters. This mechanism is called function overloading. Why to keep difference in their number of parameters is the main problem or main question, because compiler is able to understand the function call by the number of parameters at the time of compilation process itself, so that we keep the difference in their number of parameters. Let us see following example. See, in this example we have three functions named add. The type of return type of all these three function is void, but in the first form you can see there are no parameters. In the second form you can see one parameter of type integer is used, and in the third form there are two parameters of type integer. Now see, this is the perfect example of compile time polymorphism. Why, I will explain. In the first form there are no parameters. In the second form one parameter is there, and in the third form two parameters are there. Now when the call is made to the particular form of function, for example if we make the call to the add with no parameters, then obviously no doubt the call is or the function which is having no parameter will be called. If the call is given with one parameter, then function with one parameter will be called, and if there are two parameters used for calling the function, then the function with two parameters will be called. So obviously there is no doubt for making the distinguish between the function call to the compiler, as we are keeping the difference in their number of parameters. So this is the example of compile time polymorphism. And see, one more thing is there, all these three functions are performing different tasks. their behavior is different, but just to distinguish the function call we have kept the difference in their number of parameters. And another way of achieving compile time polymorphism is operator overloading. Now let us see the second type of polymorphism, which is runtime polymorphism. So in this type of polymorphism, data is bounded at the time of execution, not at the time of compilation. So after completion of compilation process, data is bounded at the time of execution, so it is called as runtime polymorphism. I will explain this in detail. Consider we have two functions of same name and if we don't keep the number of difference in their number of parameters, so it is very difficult task to the compiler for identifying the function call, because as this situation is a ambiguous situation for identifying the function call. So in this case data is bounded at the time of execution. It means the decision of calling the function is taken at the time of runtime. So this type of polymorphism is called as the runtime polymorphism, and to achieve this type of polymorphism we use virtual function in C++. Runtime polymorphism is also called as late binding, as the data is bounded in the late or dynamic binding. Thank you very much.